Recall before we finished up second semester, we did this activity. So we looked at the circle, we measured the radius, we mapped that radius onto the circle, and then we marked those down. And remember, we had a test to see, is this correct? Well, how many of these the radii fit on the whole circle? We had about 6.28, which we said is approximately equal to our 2 pi. If that was the whole circle, then half the circle is pi, and so that means 3 of the 3 radii will fit before we get to half the circle. And remember, pi is just a number. So when we say pi, we're just saying about 3.14. Same thing with 2 pi. So they just represent numbers, and we came up with a definition that said 1 revolution, or 1 circle, is equal to 2 pi radians. Now note, we don't really have to write radians. If we don't write anything there, we'll just it is assumed to be radians. And that was the same thing as 360 degrees. Now, that one is extremely important, that you must write 360 with the degree symbol. If you do not write the degree symbol, it means you're talking about radians. So you cannot assume on that case that, oh, I mean that it's going to be degrees. No, if you want degrees, you write the degree symbol. This leads to a constant. 2 pi is the same thing as 360, just like 1 minute is the same thing as 60 seconds, which when we come down to this next part, we can set up a ratio. We can say something like 2 pi is to 360 degrees, or in other words, pi is equal to 180 degrees. Half the circle in degrees is the same as half the circle in radians. Just like when we're looking at our circle, we have pi, and this could also be written as 180 degrees. Now what you need to do is train yourself to start using radians. Radians are much better than degrees. They're easier to work with. There's so many patterns that go on that will make it really nice for us. Now, you learned how to do this kind of thing last year, and what I want you to do, at least for right now, is I want you to learn about how to deal with this as a proportion. And what's a proportion? It's where 2 ratios that are equal. So we have this constant, or we could write this as 360 degrees is to 2 pi, which is the same thing as 180 degrees to pi. Now, if I'm going to try to find radians, I can say our radians is to 150 degrees. So we're going to find what is the equivalent of 150 degrees in radians. And we have a constant. Since radians on the top, we'll put pi on the top. Pi over 180 degrees. So r is equal to pi over 180 degrees times 150 degrees. And when you simplify that, you get 5 pi over 6. Now go ahead and do these two, and then check the video. So we have 3 pi over 4, and this time we're going to convert that to degrees, so I'm going to put d over that. I'd prefer to have my variable on the top. Since the degrees are on top, I want 180 degrees on the top over pi, so d equals 180 degrees over pi times, and we'll multiply both sides by 3 pi over 4. 3 pi over 4, the pi's will reduce, and we're left with 135 degrees. So you want to make sure that you understand what's going on for there, because I'm going to try to show you a lot of stuff over the next couple days in regards to proportions and understanding how you have these constants within the circle. If you understand them, it will make using some things later on easier. Now, when I look at 2.25, what is that? What is the unit of measure? You should know immediately that 2.25 is radians. Why? Because there's no symbol with it. So what we want to do is convert the radians to degrees. So we'll say d over 2.25, and we'll set that equal to, let's see, degrees, 180 degrees over pi. So we get d equals 180 degrees over pi times 2.25. Now what does that give? You just type it in on the calculator, and that gives approximately 128.9 degrees. Now this is a good place to take this and convert that to a degrees and minutes. Now you may or may not be familiar with this. So here, let me see if I can get that to show up well. There we go. 1 degree is equal to 60 minutes, and that's the symbol you would use, kind of like 60 seconds. And then 1 minute equals 60 seconds. Now this second is, and that's 2 there. And we don't, but this is dealing with degrees. It's not the same thing as time, but it is very similar to it. So when we do this, we already know that this is 128 degrees, and then we have 0.9, etc. degrees. We want to take this fractional part and we want to convert it. So we have 0.9. Now, we can't just use 0.9. We need to use the whole thing on the calculator. And I'm just going to write it for right now, 0915 ... So that's degrees. We want to see how many minutes is it. So let's say m minutes equals, what is our constant here? 1 degree is 60 minutes. And we get 60 minutes is to 1 degree. And then we multiply the 0.915 degrees. Now note, does this look familiar to you? Hopefully you're saying yes. Hopefully you're saying this reminds you of the chemistry railroad tracks, and it is similar. So we don't have to set it up like this, but I do want to see your degrees when you're doing it and not just give me an answer. So I can take this now. How am I going to use my calculator? Because I have to use all of it. I don't want to use 0.91 or 0.9 or 0.915. I want to use the whole thing. On my calculator, hit subtract. So it says answer minus 128. Now I have my decimal part, and I can multiply that by 60. And that gives me 54.9 minutes. So my answer for this problem would be 128 degrees, 54.9 minutes. And we could continue that for seconds. That's the main part to do there. Let's take a look at the next piece. Now we have this thing. It says we have 27 revolutions per minute. RPM stands for revolutions per minute. Find the number of degrees per minute. Now, how are you going to do this? Well, it's going to be very similar to this. We're going to say one revolution is how many, we're going to convert it to degrees, how many degrees? 360 degrees. 27 revolutions is how many degrees? We'll just put a D, and so we can just multiply both sides by 27 revolutions. Now, notice I left off the per minute. I could put it all as per minute. Degrees, 1 revolution per minute is going to be 360 degrees per minute. When I take my 27 revolutions times 360 degrees over 1 revolution, the revolutions go away, and I can just multiply those two numbers out. Let's see what I get. 27 times 360, and I get 9,720 degrees per minute. Remember, per is just another way to say divide. Miles per hour is miles over hours. Do the same thing for radians. Give it a thought before you watch. The only difference here is we have 2 pi for 1 revolution equals the radian for 27 revolutions. Multiply both sides by our 27 revolutions, and we get 54 pi, and this is going to be radians per minute. All right, let me give you a definition. So I want to talk about coterminal angles, but before that, we need to know what a terminal angle is. So when we're going to be talking about angles, we're going to say our positive x-axis is going to be our initial ray. And no matter where we put the angle, it could be here, it could be in another quadrant, this is going to be our terminal ray. So we start at the initial ray and we're going to end at the terminal ray. Let's take a look at here. When we do this, we can say, we'll sketch this angle. We have 80 degrees there. I want to say, starting with the same initial ray, how can I end up in the same spot? So I would strongly recommend you're stopping it right now. Think about this. Don't just wait for the answer. What we want to do is we can go all the way around the circle. Now, are those two angles the same? No. But they do have the same initial and terminal ray. What is their angle I just wrote? It would be 80 degrees plus 360, or 440 degrees. Now, is that the only positive one? No, I could add another 360 and another 360 and another 360. In fact, I can add n number of 360s, no matter what number n is, as long as we're talking about, in this case, a positive integer. Now, how can I get a negative coterminal angle? So this is 80 degrees. This time, I want to stop, and I want to go around there. Well, what do you notice about those two angles? 80 degrees and the angle I'm looking for add up to 360. So 80 degrees minus 360 will give me my negative 280 degrees. So my two angles that are coterminal here are 440 degrees and negative 280 degrees. Do the exact same thing with pi over 3. Can you sketch where pi over 3 is? Well, we know pi is half the circle. So we want to break it up roughly into 3 equal spots, so about there. So this is pi over 3. How do I get a positive one with there? I go all the way around and come back to it. So what am I adding? Well, this time I'm adding 2 pi because I'm in radians. And 2 pi is the same as 6 over 3, so that will give us 7 pi over 3. Or 2 pi would be 6 pi over 3. And then similarly, if I go backwards, it'll be pi over 3 minus 2 pi, or minus 6 pi over 3, and give us negative 5 pi over 3. And I want to do this one just because, for whatever reason, students have a hard time when you get minutes in here. It's going to be very similar to the first one. We're going to take our 50 degrees and 40 minutes, and we don't need to write plus, but in essence, that's what's there. And we're going to add 360 degrees to it. So we'll get 410 degrees, 40 minutes. Now, that's an easy one. But now we need to subtract. We need 50 degrees, 40 minutes minus 360. Now, just to make this easier to see, I'm going to take 360, and I'm going to subtract the 50, and then I know I'm going to deal with I'll have the opposite in sign. Okay. Now, how do I deal with this? Well, just like the old days when you were learning how to subtract numbers, you had to learn how to borrow, and we're going to do the exact same thing. So we want to borrow 1 from 360, and we'll get 359 degrees. So we're taking 1 degree, and 1 degree is the same as 60 minutes. So now we can just do our subtraction. We'll say 20 minutes, 309 degrees. And so our answer would be negative 309 degrees, 20 minutes. And that's it for lesson 1.